In this video, I'll be taking you through Fallback. So Fallback is the second CTF challenge from this Open Zeppelin's Ethernaut. And let's get started. So here we have this contract here. And I'll just take you through what the contract does. The contract is called Fallback. There's a mapping that maps the addresses to the IUint 256. It's a public and it's called contributions. Then you have the address of the owner. Then you have a constructor. Constructor is what is called the first time when a contract is deployed, and only that once. So here we set the owner to message.sender. The person who deploys the contract becomes the default owner. Then the message.sender, who is the owner, is given a contribution of 1,000 ether, as you can see here. Then over here we have a modifier that is called only owner, and what the modifier does, it requires that the message.sender, the person who calls the function, is the owner, and if it's not, it will revert with this caller is not the owner. So here we have this function called contribute. It's public payable, meaning it accepts transactions ether, and before it executes, it has a require here that the message.value that is sent through this contribute function must be less than 0.00 ether. So if you send anything more than that, it will revert, it won't go through. Then the contributions are mapped to whoever calls the function, and it is added to the contributions. So if the contribution of the person who has called the function is greater than the contributions of the initial owner who deployed the contract, then by default, the person who has called the function will now be the new owner. Let's proceed. Here we have a get contribution function, which is a public view, and it returns a IUint 256. So this is just to get the contribution of the message.sender, whoever calls this function, if you want to know your contributions. So the next one here is a withdraw function. It's a public function, and it has this only owner modifier. So remember, the only owner modifier up here, it says that the person who calls this withdraw function must be the owner. So here the withdraw function states that all the funds in this contract will be transferred to the owner, and not anybody else can call this, but only if the message.sender is the actual owner of the contract. Then eventually we have this infamous receive function, which is an unnamed function. You notice it doesn't have the function keyword here, it is just called receive, and here it is marked as an external and payable, so meaning it can receive ether. So a receive function is specifically designed to handle plain ether transfers. That is, when someone sends ether to the contract without any data, this receive function will handle that request and accept the ether. But here we have a require statement which states that the message.value, meaning the amount sent to the contract, should be greater than 0, and the contributions of the message.sender, the person who calls the function, should have a contribution which is more than 0. And if that is true, then this line here will be executed. The owner will now be the message.sender. So this is the function that we need to exploit. And as you can notice, the receive function doesn't take any arguments, and it also doesn't return any values. It is just a function to help the contract receive ether that is sent to this contract without any call data. So we are going to exploit this receive function over here and gain ownership of the contract. Then we'll drain all the funds in this contract. So let's get started. The first thing that we'll do, we'll copy everything that is in this contract. So let's just grab it from here. Grab that and open your VS Code. So a minute as it loads, let me sign in. We're going to paste that code. Let's create a new file here. And for those who don't know how we created this enter a folder. You can check the previous video for how we're using Foundry to solve this. So let's get going. It is called actually, I think I already have it pasted here, so let me just open it. Yeah, here we have it. So this is cool. The next thing you're going to do is you're going to write a script to deploy this and exploit the receive function down below here that we are talking about here. So let's just, here in scripts, let's create a new file and call it fallback.s to denote the script, then .sol. So here's where we're going to write all our exploit script. So I'll just start with the basic spdx. So here I'm going to do some few importations. So I'll import this should be in lowercase. I'll import from the Forge directory. I'll import Foundry's tools that I'll use to do the scripting. Then what I'll import next is our contract here, fallback.sol. Then now let's write our contract. Fallback solution. Then you're going to inherit from this script here so that you can be able to use it. So just do is script and open those curly braces. Then the first thing you're going to do is we're going to reference the contract that is already deployed. So the type is fallback, and we'll call it fallback instance. So that should be equal to fallback then you're going to grab the address at which it is deployed. So let's go back here and let's click get new instance here. Should get a prompt by MetaMask here. Here we have it. Then we'll proceed. So here we confirm the transaction. Then we'll go and open our developer tools right here. And right here we immediately get our instance address over here. So let's just grab this one here. I'll grab that and get back to our virtual machine. Then I'll paste this one here. After pasting this address here, we need to typecast it as a payable address because this contract is able to receive Ether. So let's just typecast it as a payable address because it can receive Ether via the receive function. So now let's proceed to write our run function, which will help us to broadcast this transaction. So I'll just do function run. It will be an external function. Then I'll just do vm.startBroadcast. This is where our transaction will begin to be broadcasted. So yeah, that's that. So the first thing that we need to do in this script is to first make some payment so that our contributions should be greater than 0 for us to satisfy the receive function down here. Let me show you. This receive function here requires that the person who calls it, the person who calls it sends an Ether of above 0, more than 0, and their contribution should be greater than 0. So the first thing you're going to do is try to send a little bit of Ether to this contract so that our contributions would be more than 0. Then we'll call this receive function with an amount of Ether more than 0. Then we'll now be able to satisfy this request statement and become the owner here. The owner will now be the message sender, which will be us when we call this function without any call data. So let's go and do that. So in here we'll do the first business of the day, which will be to contribute some little bit of ether into that contract. So we'll just call use the fallback instance. Then I'll do dot contribute because you already have that contribute function. Then just do this to specify the value. We'll contribute one way. Then after contributing one way, now we've satisfied one bit of the requirement. The next requirement is to call the receive, to trigger the receive function by sending ether with no call data. So we'll do that next. So for that I'll just do address of the fallback instance. Then I'll call a dot call method to it here, and I'll specify the value again. I'll again do one way. Then here we leave the call data blank so that we can be able to trigger the receive fallback function. So here this should return to us a tuple. So I'll just do this. Should be a boolean success. Then you're not interested in the rest because we have not specified any call data here. Then here I'll have a require statement just to check on whether this has been successful. Let me give it a message here. Fallback has failed, something like this. So after doing this, we've now sent ether on this in this line here. Then here we've again sent ether with no call data. So we've already satisfied the two requirements. The next thing I'm going to do is to log the two addresses so that we can see in the console logs. So let me just do that. I'm going to first log our address. So, and I'll grab it from my .env. So I'll just do vm.env address. So this I have it saved in my .env. If you don't have a .env at this point, just go to the outermost level of this entire folder, then create a .env and grab your address, your external address for your wallet, and add it here. Then down here now let me do the console.logs. So I'll log here the new owner. I'll call the fallback instance.owner method that we have with this contract. Then I'll now console log our wallet address. So at this point we've done the heavy lifting. The last thing you're going to do is drain all the funds in the contract, because at this point we assume that now we've assumed the ownership and we are now the owner of the contract. Now as the owners, we now tap the dot withdraw function to drain all the funds from this smart contract to our address, to our Ether wallet. So I'll just do again fallback instance dot withdraw because we have that function in the contract, and that will be it with this. So the last thing I'll do is just vm.stop broadcast, and we'll deploy this and see how it goes. So that's done. I'll do Control S to save. Then we'll pop our terminal and run this script and see how it goes. So the first thing to do here is to ensure that you bring in your .env variables inside this console, because these are new terminal right here. So I'll just do source.env. Then now we should be having our variables here. If I do echo something like this Sepolia URL, should be able to see it here. Here we have it. Let me first widen this window. I think now it's okay. So the next thing I'm going to do, you're going to deploy this contract here, so that it will run all this, and we will be able to exploit the contract. So I'll just do forge script, then we'll specify the file path, then it's fallback solution. I have it as fallback.s. okay, fallback.s.sol. Then the next thing I'll specify at this point is the RPC URL for Sepolia. Then I'll also specify our public key, so just our private key main. Remember that all these are available inside our .env, so private underscore key. Then let me first run this. As you can see, it is compiling here, nice and easy. So the compiler run was successful, and let me drag this up so that you can see here the information you have. Simulation complete. Then we have here the gas price, gas used, chain ID. Then here we have the logs here. The new owner is our wallet address, and as you can see, it's similar to my address here. So this means that we've gained ownership of this contract, and when you called the .withdraw, it definitely went through. So that was just a simulation. Now let's add the broadcast flag in order to broadcast this to the Sepolia testnet. So I'll just up arrow, I'll do tac, then broadcast, then I'll run that so that it can deploy to the Sepolia testnet. So with this, I believe we've already solved this challenge. So this challenge was just about to brush up your skills on the fallback functions, the receive and the fallback function. So we just said that the receive function is specifically designed to handle plain ether transfers. So that is when someone sends ether to the contract without specifying any data, the receive function will be triggered. So that's just about it about the receive, and as you can see here, we're done with this. And now when you go back here, so we come back here and click submit instance, then a MetaMask transaction request will pop up here, as you can see here. Then we click confirm. Then at this point we're done with solving this level, so let's just wait for it. So I'll just click confirm here. So right here we should be seeing that we've completed the level, And as you can see here, you can see the transaction was confirmed. You can see here, well done, you've completed this level. So that was it about this fallback challenge CTF here by Ethernaut. It was just testing your skills on if you still know the basics of the fallback functions, the receive and the particular fallback function. But here, what was being used here was this receive function here. So that's it about this level. I'll see you in the next one. The next one should be Fallout. So yeah, I'll see you in this Fallout.